Hello everyone, welcome back to the channel. If you are new here, my name is Obiko Yagbenga. I'm also known as the Data Doctor, and today we'll be diving into something incredibly important for every data analyst, every data professional, anyone that wants to take their skills or the project documentation to the next step. It's quite important for data, for developers as well out there. Every tech bro, and that is what, like you can see here, that is Git. Git. Now, if you have been following along, you know that I've already covered, how to document your project on GitHub. I'm going to attach the video somewhere here again. Although the video is not on my own channel, it's on the Microsoft Reactor YouTube channel, but it's fine. So if you have not gone through that video, if you don't know how to upload or document your project on GitHub, I would advise that you go there and do that first. So, because from there you're going to understand everything about GitHub and how to go about it. But today we are taking it a step further, right? Yes, you can document Power BI projects, Excel, and all that, but on GitHub, yeah. But then you need something else when it comes to you doing projects in SQL, Python, or coding generally. Right? I know you need something that's more technical. And in many job interviews also, it's usually asked. This is a very great skill that can be a rate limiting factor for you. Being employed or not. Okay, so let's talk about Git. One of the most powerful tools you can have in your toolkit, as a data professional is the knowledge of Git. Now, I know that when we hear Git, it might sound a bit technical and in fact maybe intimidating. You guys are not alone. Same here. But trust me, it's simpler than it sounds, and it's absolutely essential. Now, let's get started. Okay. Like you can see here, you can see Git. Let me put on my pointer. Oops. Uh, put a pointer here so you guys can follow along. Oh, this feels nice. Okay, so you can see Git here. You can also see, sorry, you can see GitHub here. You can also see what Git. So we're still going to come into, what are the differences. Okay, good. So what is Git? Simply put, Git is a version control system. Let's start with that because this is this is a term that you first have to understand before you can understand any other thing in this tutorial. So it's a version control system, as the name implies, version control system. When you have, for example, something very small, a file, right? You save a particular file, say a document, maybe PDF or whatever. You save it, on your system, and now you want to add something else, right? There are two ways to go about it. If you add something else to that file, you either save to override the previous version, or you save as to save that new version separately. Let me show you how it goes. So let's come to notepad. So let's do something, right? So I'll add a line. Let's say I am adding a line to this file, as version 1. So let's just have that, right? Now let's save it. Come to file, let's say save. Okay, let's save to desktop, and I'm going to name it version 1. Okay, and let's say save. So I've saved it here. Let's go to oops, what's this? Let's go to desktop and let's look for it. Version 1. Yeah, let's put it here. So you can see version 1 here, right? Now let's open our notepad again. Now I want to add version 2. So let's add something else. I am adding a second line, okay, to save as what? Version 2. Now you know that this file as it is now is different from the version 1 that we have here, because version 1 contains only one line. If I want to save this one now, this updated version, if I should press Ctrl S, what do you think will happen? It's going to overwrite what we have in version 1, and version 1 will be saved to have these two lines. But I don't want to do that, because once I do that, I will lose version 1 I will not know what is in version 1 anymore. So a way to go about it is come to File and say what? Save as. And I'm going to name it what? Version what? Version 2. I will say save. Okay. When I say save, you're going to see version 2 here again. Version 2. Can you see? Now, let me add a second line. A third line to save as what? Version 3. The same thing, I come to File. I say save as. Then I name it what? Version 3, right? And I say save. Where is it? It's taking some time. Okay, it's here. Version 3. Like that, and like that. So, I mean, even if I continue to add next more line, I can always save it as different versions. The reason why I might want to do this is so that I want to be able to go back to each version at every point. For instance, when I save version 1 now, I could have saved the version 1 with the date and the time that I wrote, that I created the file. I could have saved version 2 with the date and the time. I could have saved version 3 with the date and the time. So based on what I need, I might need to go back to version 1, right, to check or to go back to the file I saved at on a particular date at a particular time. So I go back to that version to check what is there. If I needed the original, I needed version 2 now. I don't need version 3 anymore, because you see, in a corporate setting, in organizations, you can be amazed by the request that you get. You can do a project, and at the end of the day, the one you did previously is what they actually need. So you go back to version 2 and say, this is what I need, and you push it or you upload it to the client or whatever. So this that I've just shown you guys is version control. I think it's clear like that. This that I showed you, I'm trying to take my time, because if you understand what version control is, you'll be very good, right? So this that I showed you guys is version control. We have version 1, version 2, version 3, blah, 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 like that. And that is what Git does to you. That's what Git does for you. It helps you control the various versions that you have. Now, what is Git? When I say what is Git, Git is actually a software. Now you'll be noting a possible difference between Git and GitHub now. Okay, Git is actually a software. It is a tool, right, for version control. So when you say what is Git, simply Git is a version control system. It's as simple as that, right? But it's not just any version control system. It's what it's called a distributed version control system. Let me leave that for now. Okay. Yeah, I think that's basically it. Can we move on? So, what do you have here? Blah, 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 blah. Open source. If you know what open source means. So this is a server. All right. A repository, you have developer 1, developer 2, developer 3, blah, blah, blah. I'll come back to explain all this. Let's move on. Now, difference between Git and GitHub. Now I've told you what Git does in your system, right? What Git does in your system is it's a software, it's a tool, it's different from GitHub. When you download it on your system and you save it as a repository, or you save it um, under the Git tool or under the Git software, Git automatically controls. For example, those files that I just created, like version 1, version 2, I don't need to do all that when I have Git. You understand? I can always once I have Git on my system, Git will automatically save every new version that I put on. You understand? When you write something, I wrote the first line, I save it. Once I save it or I commit, those are the terms you're going to be familiar with. Once I save the version 1 and I commit it, okay, Git automatically tracks that. So what Git does is that it tracks versions, you understand? So it automatically tracks my version 1. Then I go back to that file. I add a second line. I save it or I commit it. I don't need to do all those save as or whatever. Git automatically tracks it, and it does not just track it anyhow. It tracks it with the date and the time of the commit. You understand? And that's what Git basically does. You understand? So it's quite different from GitHub. From here, you can see that Git is actually to be installed on the laptop, on the system, on your local machine. GitHub is a space online. Do you understand? So these are the basic differences. So I went online. I saw quite a couple of resources that I think would be very, very beneficial to share. Okay. Yeah, so let's look at this. I think it looks blurry, but I think it's fine. I just saw it online, but like, okay, I think this is nice to also share. Well, I'm going to read out. Git was first developed in 2005. I don't think I need that information. Yeah, so Git is installed and maintained. Where's my pointer? Yep. for pointer. Yeah. So we're here. So Git is installed and maintained on your on your local system, like I said, rather than in the cloud. You understand? And one thing that really sets Git apart is its branching model. We're going to come to explain this later, but majorly, what we are saying in essence is like so mentioned here, Git is a high quality version control system. So if there's anything you are taking, if you will not be taking anything out of this tutorial at all, is to understand the fact that Git is a version control system, and for you to understand what version control means. Now, coming back to GitHub now, it's designed as a Git repository hosting service. Of course, it's online. It's exclusively cloud-based. You can see that. And you can share your code with others, giving them the power to make revisions or edits, right? So GitHub is a cloud-based hosting service. So for example, those files that I created, the version 1, version 2, version 3 that I created. So one thing that I've exhibited is I've used Git. I can use Git to what? To control, to monitor, and to track the versions. A second thing is that if I'm working in my organization, okay, in a corporate organization, what you do majorly as a data analyst or as a tech person is that you would hardly work in isolation, right? Because you guys be working on a project of the company, right? So there's no way you'll be working in isolation. You've got to work with other people, and that's why collaboration is one of the most important soft skills you can have, as a tech professional, as a data professional. You understand? Now you have to collaborate with someone else. Let's now assume that that text file that I created, right, is on my laptop. I need to share it with someone. I need to push it, to the other members of the team, right? So I would not say, oh, come and check my laptop and see what I've done. No, I wouldn't do that. So it only means that there has to be a central repository. There has to be a central place, a hub, a place where every other person can go and check what I've done. You understand? And that is the importance of GitHub. So you use GitHub to share those things that you've done on your laptop, on your own local machine. So you push it. You heard the word push. So you push it to the repository on GitHub so that other members of the team can access it, can check it out. Okay, if there's any update that they also need to add, they would add it. They will push it again to the same repository, like that, like that, and like that, until the manager or the final person or the senior person sees it, approves it, and it is pushed to publication. It's as simple as that. So you don't work in isolation. Very, very important. It's a very important skill, right? Collaboration is key. Yeah, so I saw this also to just to outline things. So Git is a software, like I said, and whereas GitHub is a service, Git is installed locally in your system. So we're going to do this. We're going to do that much after this presentation, and whereas GitHub is hosted on the web. Yeah, Git is a command line tool. So command line tool is like you have your command line. Those that black interface where you have to type very boring stuff, right? So it's basically a command line tool. It also has a graphic interface actually, not only GitHub. This is GitHub provides a graphic interface. So Git has a graphic interface as well. But we need to learn the command line too. We were going to do that much later. Git is a tool that manages different versions of, like I said, different versions of edits, made to files in a Git repository. So the moment you want to create a file and you want it to be tracked, you just save it in your Git repository on your laptop. The moment you give Git the permission to track it, it start doing that for you. However, for GitHub, it's not to track versions, but it's a space where you upload a copy of what you have done on your laptop, right? You upload it there so that other people can see and perhaps updates or whatever. And lastly, it provides functionalities like version control, system source code management, like I said. But GitHub provides functionalities functionalities of Git, like version control systems, source code management, as well as adding few of its own features. So the versions that are actually controlled by Git, they would also be visible on GitHub, and that's why you have this statement here. You understand? So if you go to GitHub now, you see somebody that have committed different times. There's a version, second version, third version. By the time you go to that person's GitHub and you see it, you're going to see the number of commits the person has done. You're going to see the number of versions the person have uploaded. So whichever version you want to pull or you want to update, then you can do that. And that's why this statement is actually mentioned. But what actually does the version control is Git. Good. So this is just to bring it to more practicality. So let's look at this together, right? So we have GitHub, we have Git. We are trying to differentiate what Git and GitHub is, right? So let's look at this person. So this says that this is workstation or PC computer number one. So this can also be like say developer number one. Okay. Say this is another workstation developer number two, another person developer number three. Now, when they let's say when they employ this person into the organization, I mean into the company, they want the person to start working on a particular project that has been started already or to start working on a code. You understand? You want to work on, you want to do some machine learning, you want to build some machine learning algorithm. But the data is there, the code is already there already. You just add to add, some functionalities to the code, right? So definitely they're going to give you access to the central. So this is here we are trying to explain what distributed version control system means now. Now they'll give you access in the company will give you access to what? Perhaps your manager will give you access to the central repository. Now, the central repository can be on GitHub or it might not be on GitHub. So GitHub is not the only, online hub that you have for projects, right? So they can have their own as in the company. So it gives you access to the central repository that is where the major and where everything goes on. So you are going to create your own repository on your on GitHub. Let's use GitHub now on GitHub, right? When you do that, you are going to pull you understand? You're going to pull the needed code or the needed file that you need from the central repository. You can see the arrow coming down. So you are going to pull the needed um, file that you need. When you pull it to your own repository online, you understand? And so what I mean by your repository online means that your own GitHub profile or your GitHub page or GitHub account. So let's say this is your GitHub account here. So you pull it to your laptop, you download it to your laptop. Okay, when you have it on your laptop, look at this place and look at this place. So what you have here represents what you have here. So this is explaining it in terms of Git and GitHub. This is explaining in terms of general stuff, right? So again, let's go over it. This is central repository. Understand? You pull what you need to your own repository locally now. This is your laptop, right? And when you have it on your laptop, you do whatever you want to do. You add the code, you update, you do everything, blah 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 blah. You commit. Commit is like you save, like I saved the other time. And when you save, what do? You push it back to the central repository so that your manager can see it or your senior professional or whatever can see it. Now, let's come back here again. This is the central repository. It represents what? Which represents the GitHub, right? So you pull it, you understand, to your laptop. You pull it to your laptop where you do your work. Now, on your laptop is where you have Git, right? Which is the what software. Now, when you do something and you update it, let's say you updated something version one, right? Then you come again. A lot of things can happen here before you even push, right? So you update it, that's version one. Git tracks it with the time and date or whatever. You do another thing to update it again. Version two, Git tracks it again. Version three, like that, like that. So all your versions and tracking and commit, Git does all those things for you locally. And when you are done, you commit it, you save it finally, and you push it back to GitHub. So that is where the difference between Git and GitHub happens. Now, this is another person so this is another person, developer 2. So let's say the developer 2 wants to update your own code, what you have already pushed finally. He wants to update it, do some put in some AI functionalities into it. So pulls your own final commit or your own final save, pulls it to his own laptop, works on it, does his own thing. So he can also have various versions as well. When it's done, it pushes it back to the central repository, which can be GitHub or something else. You understand? So perhaps this person is like the final person or whatever. The person also pushes the final commit of this AI person, okay, pulls it to his own laptop, does his thing, does his updates or whatever, commits it and pushes it back to the central repository. Now from the central repository, perhaps the manager, which is the person that will now maybe deploy it for the client or whatever. So and that is how collaboration works, right? So GitHub helps you with collaboration, okay, and Git helps you to track what changes. Okay. Now the changes that you have done, let's say this person did three commits or three changes. This person, the next person, does not only have access to your final commit, you also have access to all the versions. Let's say this person has made like three versions of that thing. Those three versions will also be visible on the server, right? Say on GitHub. So this person can see them. So it's not only the version, I mean the final version. So this person can decide that, okay, let me look at the second version based on the requirements, okay, and update the second version. Same thing with this person. So it looks a bit complex, but it's quite straightforward if you follow what I just explained now. So the first person can track his own changes, even the next person can track the changes of this person, the next person can track the changes of this person. So everything is open, collaboration, and all that. It helps, which is really, really amazing. Good. So here we're also trying to explain. So what I just explained here is what is called distributed version control system. Like the name implies, as you can see, this is this is a central repository. See how distributed it is. This person can pull, this person can pull, anybody can pull at any time. You understand? Yep. Good. So same thing happens here. This is a working, copy. The person has a working copy, he works on it, does his commit, pushes it to the server. This person pulls it, works on it, pushes it to the server. This person pulls it, works on it, and pushes it to the server. That's basically distributed version control system. All right. So this also, gives us a bit of, insights into how to, what version control flow is like. So you see that this also resembles what I just explained. So this is a central repository, say like your GitHub. Now, James created a file, called it project plan, a document, right? Project plan.doc, which is the version one, right? Now, here we are not even talking about tracking changes now. We are just talking about how, we can have different people working on the same thing. You get it? Now, he said, okay, he had a version note. This version note is called, when we start working with Git, it's called commit message, right? He said, oh, template created. So he created a template. Now, so here now, he would have pushed this to the repository here at this point. This person, Laura, pulls it from the repository. Okay, checks it. Then, oh, this same document created a version 2. Why? By what? It said WBS and OBS added. So it added some other things to the same file. Okay. When she does that, this message will be seen by every other person that have access to the repository. This person does the same thing, pushes it to the central repository. You understand? From the central repository, Joe pulls it. Okay, so Joe pulls it. Also, did some editing, updated it. It says, oh, budget plan added. Now, the eventual or the final, version that is created, they send a request for approval by the manager. The manager or the project manager approves it, as the final version, and it says what? Ready for stakeholders. So you can see that that's how collaboration works. Everybody works in collaboration. So that's the importance of Git and GitHub, and that's how it works. Good. So this also explains distributed version control system. As you can see, this collaborator one, his own local repository at his own laptop. So a repository can be either local or remote. So when you hear the word remote repository, we are talking about this central repository here. His own repository on GitHub. You understand? When you say your repository on GitHub, all those repositories that you created in your GitHub profile, in your GitHub account. That's what we call the remote repository. You understand? So you can have a local repository on your laptop. Okay, so this person on his own laptop, he has his local repository. He does his, he does his updates, blah blah blah, edit and everything. Commit it to his own local. So when you say commit, is like you're just saving. It's as simple as that. So commit it to his local repository, right? Because you cannot just push whatever you push to the main server repository or to the central repository. It has to be from your own local repository. So pushes it to local repository. You understand? If you need to pull it again, you can pull whatever he wants to pull, work on it, pushes it back, pull, push like that. You understand? Same thing happens with this person. Pulls whatever version he wants to update it on his own computer. Remember, Git is on the computer, tracking what? Tracking the changes, right? Pushes it back to the repository. Same thing with this person, and that's how it works. Look at what it said here. Each collaborator. So this is explaining a distributed version control system. It says each collaborator has a local copy of the repository on their own laptop. So no internet connection is required. Do you get it now? So the moment you pull, you understand? The moment you pull to your own laptop, you start working on it. Even if there's no internet connection again, you can keep working on the project. Okay, that's different from a centralized version control where everybody's just working on the same repository, directly. So at the moment the position has an issue like this, you cannot do any updates. So and that's the importance of distributed version control system. So let's look at, so why Git again? I'm sure I've mentioned some of the things here, but let's look at it again. All right. Because the moment we understand the importance of these things, I mean, the easier it will be for us. So Git is important for version control, like I said, to track your what? Your changes. Because sometimes when you write a particular code, right, that works, wrote something in Python, that works. Then after that you update it, you delete some of the code, blah blah blah, something happens along the way, along the line, and you just save without tracking it. It means that what you wrote initially that worked, you can't have access to it anymore. I mean, so the importance of version control cannot even be overemphasized, right? And that is that collaboration, like we said, GitHub is there for you for collaboration. Collaboration, Git also works with collaboration because your fellow developers or your fellow team members, they can see how you have. They can also track your work. Okay, so which gives room for great collaboration. Backup and recovery. You see, when you work on a project and you push it to GitHub, right? Maybe you worked on something, the versions that you worked on, you push them to GitHub. You are rest assured that even if anything happens to your laptop, you can always, fall back on, the storage on your GitHub, right? So GitHub will also create a storage for you, right? So you can always have backup and recovery, and that's important. I mean, that's what that means. Branching and experimentation. So what we are saying is that, let me come back to the previous one. Um, ah, all right. I mean, just to explain branching. So let's use this one. Say there is a code here in the central repository. Okay. And this code that you have inside the repository is what the customers or the clients are using. For example, now let's say for WhatsApp now, the repository WhatsApp is the very common social media app that we have for messaging. So let's say this is the repository for WhatsApp. You are working in a WhatsApp company. They ask you, okay, try to experiment some things, and for you to experiment some things, what do you need to do? You need to pull, right? You need to pull the code. So when you now pull the code, when you are making changes just to experiment, you cannot, it's only logical that you don't work on the code directly, because when you work on the code directly, it may eventually affect what experience of the users, right? So what you do is you can create a branch. That's where branching comes in now. So you can create a branch. When you create a branch, when you want to edit something, you're gonna have a lot of versions, right? Definitely, because it's an experimentation. So, but when you create a branch, you can do whatever you want to do along that branch. It's as simple as that. Okay, so without affecting the original code. So that's where branching and experimentation comes in. So documentation and accountability. Yes. So what we mean by this is that Git makes it possible, gives you who wrote a particular code, or who did a particular commit or saved a particular code at a particular point in time, when it did it, who did it. You understand? So, and that's what documentation and accountability brings. All right. Now, it's important that we understand some, like I said, some terms, right? Before we get started with actually, walking through how to go about Git and GitHub, right? So there's some registered. I mean, you have seen some that you know about here. So I mentioned local repository. I mentioned what remote repository. Staging, commit, branch, merge, push, pull, clone, fork, pull request, and many more. I mean, many more. I just brought this as I think to start with, you should understand all this. Basically, you can always read more on other terms, right? Now, I guess you understand what local remote repository is already. Push and pull, but I'm going to explain it otherwise, right? I mean, by the way. So you see the word repository, it's like a storage space, where your project lives. That's where your project lives. So your project, before your project can live online, most likely it should have lived offline on your own laptop, right? So your repository contains all the project files that you have. You understand? And also contains the history of all the tracking, all the versions, blah blah blah, all those things. So all the versions of those files that you've created, everything is housed inside the repository. You understand? So the repository can either be what? Again, a pointer. So a position can either be local or can be what? Remote. Okay, so when the position that is on your laptop, of course, is the local one. The remote one is the one that is what? Hosted on platforms, hosted in the cloud, like GitHub, right? And that is that. Now, staging. You see, this staging, while I was learning it during my own time, it's just quite funny. The reason why it is funny is because normally by default, in our own minds, when you want to save a file, do you stage it? Is there anything like staging? No. So it's quite funny that there's there is the idea of staging in Git before you can save. Like I said commit. I'm still coming to commit. Commit is like you just want to save something, right? But staging is that it has to come before you commit. Commit is like, let's say, okay, you want to take a picture because that's what happens, right? Git takes a picture or takes a snapshot of your file at that point in time, registering the person, registering the time, registering, the date. But before you take a picture, what do you have to do? You have to get ready for the picture. For example, for ladies, they will do the makeup, they'll adjust their hair, they'll do this, they'll do that. Even for guys, put on their spectacles if they have, adjust their face cap, blah blah blah. All those things you are doing while you are preparing to take your picture is what we can call staging. I mean, you are placing that thing on stage to say and action, something like that, right? So when you stage, right, or let's say there's something we call a staging area. Okay, so a staging area, or stage is where all those changes that you've made here. Example, we've saved. What we did initially was version one locally in local repository. I now do version two. When I did version two by adding the second line using the same example I started with, what I will do next in the idea of Git is I will stage it. So what I'm saying is that all those changes that I made, that second line that I added, I have staged it. All right. So staging area is the place where changes are held before you commit. As simple as that. You are just holding it somewhere. Yes, the idea is not something that is common in our day-to-day activities, but as far as Git is concerned, you have to stage whatever change before you commit it. Because you see, when you are doing very, very complex or very, very, how do I put it now? Delicate stuffs like someone that works in Google now, something that you don't just commit anyhow. So the issue of staging is just trying to be extra sure that are you sure you want to save this? Because sometimes you do some saving and I mean, you really hate yourself, So I mean, I think that's just the idea. So when you make changes to your file, what you do is you stage them, which means that you are preparing them to be what committed. You're preparing the changes. Oh, I want to get them ready for committing, just like actors get ready for shooting. It's as simple as that. So, and this lets you choose. For example, like I might have done. So what happens is that, for example, now I have a file, that's an original file that I called version one. You understand? Oh, I had second line. So when I had the second line, when I had the second line, I feel like okay, do I add just second line or okay? So when I add second line, I say I want to add second line. That's what I wrote in the second line. You understand? I stage it. Ehen. When I stage it, I've just staged it. You understand? The second thing I can do is that this second line, I don't know which one to write there first. Do I write I want to add second line or I am adding second line? Okay. So I come again to add another change on the second line. So I come back to the version one again. You know that version one is still there. So I come back to the version one and I write on the second line, I am adding what? I am adding second line. Now we have two changes that I've put there now. The first change is that on the second line, what I wrote is what? I want to add second line. You understand? Okay, or I want to create version 2. The second change is that on the second line, what I wrote is actually different. What I wrote is that I am creating version 2. These are two things. So I can stage both changes. When I now make a confirmation from my manager or whatever, when I conclude, okay, this is what I want to, commit, then I'll now commit whichever I want to commit. So what staging helps you do is that it makes you choose which of the changes that you want to include in your next commit. I mean, I want to believe that is clear enough, right? So let's move on to commit. So commit, I mean, quite straightforward, like I've always mentioned. I said it's like a snapshot of your repository. A simple way to explain it is like as if you are saving your file, saving your changes. You understand? So it's like a snapshot of a repository at a specific point in time. So what it does is that Git, when you commit, a particular change, what Git records those changes that you have made to the files. You understand? So now each commit has a unique ID. You understand? That's a unique ID. And it usually includes a message. For example, you remember the message. Remember the message that I mentioned about. Let's really go back there. Someone put something like this, right? This person uploaded something and commits it, right? And it says, "Oh, template created." This person edits the version and says something like that. This one says budget plan. All these messages are called, in terms of in the Git register, is called a commit message. Okay. So you cannot even commit without adding a message. You have to add a message, because when you do something, you have to tell somebody. It assumes that, okay, you want to collaborate with someone else, or even with yourself. You could have written a code somewhere sometime last month, and you, the same person that wrote the code, you come today and you be like, I mean, why did I write this code, or what am I trying to do? You understand? Or why did I save this file? So there's always a commit message. Okay, so it's a message that describes, oh, this is the change that I've made. Even if you go to GitHub and you look at it, let's say you had a file, you uploaded a file. If you upload a file on GitHub, say you upload, say, an Excel file or anything at all, you upload an Excel file and you say commit. Look at it very well. The pop-up that comes is you are going to see an automatic commit message there saying uploaded blah 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 file. You understand? Or when you add to your README file that you created and you commit, what will be written there is that what? I don't know, created or updated README file. So those are commit messages. So all these things, you're going to do them yourself when it comes to Git, or when it comes to you working on the command line, which I think is beautiful. So these are the skills that are usually needed by companies, and I think they are pretty much you know quite straightforward. Now, branch, like I said, you are creating a branch. Okay, there's a central repository. You want to do some experiments, or you want to do a lot of things, which will require that you have different versions. Will require that you do some trial and error. Require that you do a lot of things, right? So, and you cannot just be doing those things on the central repository. So what you do is that you create a branch. You get it? So you create a branch from the central repository. It's like there's a tree now. Let me see if I can draw something here. Okay, let me put it here. So it's like there's a tree. Let's do this. There's a tree. I believe the central repository. Understand? So you now want to work on something. So what you're going to do is you're going to create a branch. You understand? So say branch. Oops. So you create a branch. So you do your own work. Now, in the branch that you created, this is the branch I just created. In this branch that you created, you did a commit. You wrote a code, right? Okay. Then when you wrote the code, oh, you need to update it. You did another version again. Hmm? You have another version here. Okay. You need to do another update. You have another version. You understand now? Like that, like that, like that. So all this will not affect the central repository. So another person comes, maybe there's another thing he wants to do, he creates another branch too, creates his own branch as well. Okay, another person comes, he creates another branch too. And that's how these are how things work in big companies. You understand? Experiments keep going on, creates another branch too, like that, like that, and like that. That's how things work in big tech. And I'm sure, someone watching this this video wants to work in big tech someday, right? So that's basically it. So a branch is a separate line of development in a repository. For example, I did the central repository. Let's do that again. You now have something like a tree, another one here, another person here, another branch here, another branch, like that. So it's a separate line of development in a repository. You understand? So the default branch, hmm, in Git is called the main or the master branch. For example, here now you can see that this, okay, is the main branch, main branch, or we call it master branch. So when you see all these terms in, say, on GitHub, so you will know that. So when you upload something on your own repository, you're the only one working on it. You understand? What you're going to see there is you're going to see master branch slash main branch. So this is the main branch. You understand? Now all these other ones that are branch that are created by people that would just want to work on some specific features. Okay, so it allows you to work on different features or fixes in isolation. So you're working on this in isolation, not affecting the central one. This one is working on this in isolation like that and like that. You understand? So that's that about branch. Now merge. Now when this person works on something, you understand? When this person works on something and wants to merge it back to this, maybe added some code or edited some things. You understand? So merging is the process of integrating the changes of one branch into another. Either you want to integrate the changes of this way. So let's say these people now, the two of them like this, they are working on AI. Okay? Let's say they are working on AI. So this person is working on something, this person is working on something. At the end of the day, the two of them want to merge things together. This is what they do. Merge it. You want to merge what you've done here to this, or this person wants to merge what is done here to this. Understand? This person too is working on something else. They can merge it. Maybe at the end of the day, they will now eventually merge to the master like that, and that's how it works, right? So merging is the process of how do I put it now? Integrating the changes that you've made in one branch into another branch. So and that's commonly used to bring changes from a feature branch into the main branch. So this is a feature branch. All these ones are called feature branch, and this is the main branch. You understand? So if you wanna want to, the changes that you've made to the main branch, what you do is what you merge. After that feature is complete. All right. Next is clone. Okay, next is push. So like I said, so push is the act of what you have locally on your laptop or on your system on your local repository. Push is the act of you uploading your local commits to a remote repository. For those that have watched the video on my GitHub, what you are doing uploading on the GitHub is you are pushing actually. Although you're not writing code, you're just uploading normally, but what you are doing is you are pushing. So you are uploading your local commits or your local changes, whatever, to a remote repository. So after you make changes locally and you commit them. So what you do is you push them to share those changes with other people, right? Good. Now, pull. That's just it. Pulling is now when you now push what you put, you push it to the repository. So for other people to share. So how do the other people be able to access it? So they can only access it by pulling it. Remember what we said here. This person sends it to push it here. Or this person wants to work on it, then the person pulls it. Do you get it now? The person pulls it down. So and that's what pull is. So it's the process of fetching and integrating changes from a remote repository to your own local repository. You understand? So, and that's it. Um, so now let me mention one thing. This pool contains two things, right? This pool contains merge and another term called fetch. You understand that when you say pool, you have done two things together. Okay, so it combines fetch. Fetch means download changes. So you understand the changes that you have in that repository, download it and merge and integrate the changes to what you have already. You understand? So that's basically it. What else? What else? What else? Clone. Like the word clone means. You know what clone is now. Clone is like you are creating a copy. You understand? Of a repository on your own. On your own local machine. Maybe from a local machine now. There's a repository. You don't just want to pull one change or whatever. What you want to do is you want to clone the old. I want the old repository on my laptop. So that's what clone does. Clone does not just say, "Oh, let me copy." What you are copying actually is the whole repository from the person's GitHub or from the company's GitHub to your own local machine. So when you clone a repository, right, you get the entire history of all the changes, everything along with all the branches. So you can see that there are use cases for each of each of these things, right? Good. Fork also, right? Um So what you're doing by fork is that you are creating a personal copy of somebody else's repository, right? So it's often used to contribute to an open source project. Clone is different too. You might be confusing it together, right? So clone is just creating a copy, you understand, of the repository on your laptop. But fork is when you want to Like open source repository. Let's say that somebody that wrote pandas. Now there's a repository for pandas. You understand? I want to because it's open source, I want to contribute to that project. So you use fork majorly when you want to contribute to a particular project. So you fork the project. What you do is you fork the project, then you make the changes, then you submit because the owner of the pandas now, the owner of pandas library, has to approve that okay, what you've done is it makes sense, right? So you submit the changes, those changes back to the original repository. So you submitting the changes back to the original repository is what they call pull request. You can see how everything follows along now. You understand? So and that's what they call so pull request is a way of you proposing that okay, I have seen that I want this change to be implemented in the pandas library. You understand? So what you are doing is you are proposing changes to a repository. It means that the owner of that repository has to approve it or has to accept it. You understand? So what happens is that the owner of the repository will review your changes before they now merge it to the main branch. So everything makes sense, they're just different terms and you understanding the nitty-gritty of things, so you use pull requests in collaborative environments, people that are working to build something, and all that. So basically, there's also something called I think Git diff. I mean, those are the things we have to know when we get to the command line now, right? Where you try to see the difference between one version and another. I mean, it's as simple as that. Okay, so understanding all these terms is actually crucial for effectively using Git in both solo and whether you are working alone or you're working collaboratively, you know. So as you become more familiar with Git, these concepts will become more like second nature to you, and it allows you to focus more on your coding and your data work. So you can see that I mean how important these things are, right? And I mean, and now I think you can see now why some companies will need you to understand Git because there's no way you're going to get into blend into the culture of the organization if you don't understand Git. I mean, how do you collaborate? Except you have to teach you everything at every time you want to upload something, right? Yeah, good. So this is the last part of the presentation before we get into, going about the real work. I think that should be perhaps next episode. Now, Git workflow. How does it work? So we just want to take you. I just want to take you through how everything works from your laptop. How it gets to the remote repository. Blah blah blah. So we are starting from this place. You understand? So what we call the working directory is, the directory. When you hear the word directory means like folder. That's the meaning of directory. All those directories you have on your laptop, documents, download, desktop, all those things, those are directories. Or you create a folder, those are directory. So, and when you want to create work on a particular project, the project will be in a directory now. It has to be in a directory, in a folder, so that all the Git, integration, all the staging, all the version, everything will be in a particular folder. You understand? Good. Now, so this is your working directory. So in this working directory, let's say you are working on, you created a file, okay? Like I did, I created a file. I wrote the first line, a text file. I wrote the first line. Understand? Now, when you create a file, you write a first line. What did you do? That's a change, of course, right? So what's the next thing you do? You say you save it. I mean, normally you save it, but remember, I said before you save in the terms of Git means what? Commit. Before you commit, I said you have to do something. Stage it. And when you stage it, it means that you are preparing it for what? Commit. It might be funny that why do you have to stage, and I explained that already, right? Now the term or the function, or what would I call it now? What you need to tell Git to get it ready for a commit, or what you need to tell Git to put that change in a staging area, okay, is what is called Git add. So what this means is that add this to the changes. Add this change to what we have already. Okay, get this change ready for commit. So when you are done making a change, you're adding a file or you're changing whatever code or a line of code or whatever, the next thing to do is what? To say git add. When you say git add, what does it do? It stages the change. And that your file moves from the working directory, it's still in the working directory, to a place called staging area, like I mentioned. place where you temporarily store your changes, getting ready for commit. Now, when you say Git hard and it stages your changes, what's the next thing you do? When you are sure that, oh, this is the change I want to commit, then you do what? You commit, which is what the Git commit command. So these are just commands, right? So this Git hard brings it to the staging area. Then when you say Git commit, when you commit, what it does is that it saves it into the local repository, and Git tracks that with the time, the commit ID, the commit message, blah blah, blah everything in the local repository. Local repository means that what the position you have on your laptop saves it there like that automatically. You understand? When you now say, okay, I think I'm fine, I want to push it to the remote position, that means I want to push it to GitHub. You understand? So what you do is what the command you use is what git push, then brings it to the GitHub. So at this stage now, let's open this. So at this stage now, right? This is all it entails to put something on to push something from your own sorry, I'm trying to do something funny. I don't know what I'm doing now. Just trying to get things. Yeah, this is all you do from you working on your laptop, making changes, writing code, pushing it to repository. So you need to know, what are the staging levels? What are the staging? Sorry, I said staging. What are the different areas that your project will pass through if you are working with Git from your laptop to the repository, to the remote repository? So what are the stages? First is the working directory, that is the folder you are working in. From there, when you make any change, what do? You stage, then move to the staging area. From the staging area, you commit it. Commit takes it to the what? To the local repository. And from local repository, what do? You push to where? To you push to the remote repository. Can be your what? GitHub or whatever. And that's it. Now, on the other hand, say you want to pull now the code already, or someone else wants to pull the code, someone that works in your company or a colleague wants to pull the code to update it or something. Then what it does is what? From your remote repository, it pulls it, or you pull it back to your laptop. So when you pull from remote repository, that means you are pulling it back to the local repository, you know, and checkout brings you back to your working directory. You do whatever you want to do, you go back to that cycle again, git hard, commit, git push, like that, and like that. So that's majorly the workflow. And with this, I think we have explained a good introduction. Next is to move into how to download Git, how to install it. Also learning some, some bash, some bash commands and all that. So I think this is nice for you. Get ready for the next.